So I'm just doing this new video and it's about, well, let's just have a look at the actual Stack Overflow question. So I'm just going to pull it up over here, which is this question. It's actually been closed down, but it's actually quite an interesting question in a way. It's how to brute force a puzzle. Basically, I discovered that this actually doesn't work here, and we'll see this quite quickly. But here is an old puzzle you can solve using brute. Can you solve using brute force using a computer program to check all the possibilities? In the calculation, 43 plus 57 equals 207. Every digit is precisely one away from its true value. What is the correct calculation? Now, I'm going to do a little variation of this because I think every digit might mean turning a 4 into a 5, or turning a 4 into a 3, and then turning a 3 into a 4, or turning a 3 into a 2. So it's precisely one away from the true value. Or should it mean every number here? So 43, does that become a 42 or a 44? And 57, does it become a 56 or a 58? And likewise for 207. So if I was to somehow on my little G plots just go to the pencil, so 43 could become a 44 over here, or it could become a 42. And I'm just assuming that's the question. We can semantically argue about it. Could the 4 become a 2 or a 5, and so forth? But I'll keep it to the more simplistic case. But we could, or at least I'll leave that as a question to extend it to a more complicated case if it was a second version of it. But 57 then could become a 58 or a 55, 56 over there. And finally, the 207 could become a 208 over here, or it could become a 206. Now, maybe this does lead to the first version of it being the case, because these two numbers, 44 and 58, there's no way of them adding up to a 200. So this two handle kind of like looks incorrect on that. Now, I'm just sort of like wondering, just off the top of my head, if that 4 turned into a 3 and that 5 turned into a 4, we'd have a 3 plus a 4. And would that work? No. And so I'm not necessarily sure either ways would actually work. But so we'll just continue on with the actual case as it is. So the next part of it is, so we go moving on then to the actual code itself, and I've pre-written the code. There wasn't like, but the code is relatively simple. Now, someone's put here, what have you tried, what errors have you encountered, and so forth. This question wasn't really asked that well. It's kind of like ambiguous, like, oh, be scared to answer this question, in the sense that you answer it and you get voted down because your answer wasn't, or at least you interpreted the question in a different way to someone else because there was ambiguity in the actual question itself. So anyway, what is the correct calculation? And again, like, this one gets really bad responses normally. It's got the 2 downvotes. The AI didn't come up with the answer, as in somebody just banged it into a Chat GPT, a Google Bard, or a Corsair AI, or a Claude AI, or any of the other AI, the large language models, and it didn't understand the question. Well, this is a badly written question anyway. So even if you were going to prompt engineer, you would ask it in a better way. And so they couldn't do that, basically. So, or at least a large language model couldn't come up with it. So I've written a piece of code that does work. At least it works for the first case that I talked about, where the 43 could be a 44 or a 42. And how I look at this problem is like that, or at least how one could look at this problem. Now, you can come up with better solutions. I'm sure there's a more elegant solution just off the top of my head. But something that came to mind, and I haven't used this for a long time, is itertools over here. And that's well, it's all a functional tool. It says right here at the top, actually, the functional tools for creating and using iterators. And basically, the method that I want to try and do, or the approach that is being taken here, is I'm going to just say, well, if 43, in theory, this could be a 42, it could also be a 43, or it could be a 44. So it can be out by exactly 1. Now, again, like, it's ambiguous. Could it be a 43? Like, can we eliminate this case in the middle? Don't know, but let's just leave it in there. And the 57 could be a 56, or it could be a 57, and it could be a 58. And finally, the 101 is the answer, because that could also be out by 1. It could be 100. Sorry, I changed that to 101 to make it work, but let's just go back to the original question. 207 there, so 207. You see why this doesn't work. So this could be a 206, a 207, and a 208. Oops, that's twice I've done that. So, and we can see that 42 plus 56 has got no hope of being anywhere near 200. It's going to be close to 100, and that's kind of like why I stuck in a 100 at the end over there to like get it to work. But we'll stick with the 200 anyway, just for the sake of it. So what we do is I put this into 3 vectors. So we got A, B, and C, and the reason why is because, well, I've used tuples here. You could use lists, whatever, but it's not going to change because once it's set. So I've used a tuple. So I put it into these 3 tuples, which represents vectors here, and so this is the 42, A minus 1. So whatever A is, we're going to take 1 off, and then we're going to use A, whatever A is there for the second one. So we've got a 42, 43, and a 44 constructed. Likewise, we've done the same for B, and finally, we've done the same for C. And then from that, I use this function here, and this is why I use the itertools. We can see what this function actually does. I was kind of like looking for it, and I needed to pull out an AI. Now, if you're going to do prompt engineering, attempt to prompt engineer in the correct way, and I think I managed to do that in the sense that over here was the actual question that I've got. So Control plus a few times. So I zoom in so that everyone can see the actual question. There we go. In Python, so the actual question, this is a bit better. Get all the combinations of 2 vectors in Python. Right. In Python, you can get all the combinations of 2 vectors, assuming you mean lists or arrays. And I do, in fact, mean lists or arrays. In fact, I mean a tuple, which is you could call it a special type of list, by using a nested loop, or by using the itertools.product function. Now, I jumped straight to using the function, but you could use a nested loop. A nested loop is fine, I think. But I believe a nested loop is slightly slower. I don't know if it mentions the slightly slowness of it. And the reason why is I'm quite sure that you're appending a list here. I don't know exactly if the itertools.product does some sort of vectorized version. So I'm assuming normally the inbuilt stuff is a bit more efficient. But anyway, you could use either or. itertools is built into Python, so you might as well like use the built-in stuff. So I didn't have to do any like pip installs or anything to get that working. So I'm going to use the itertool, and it gives a little example here. So if you've got vector 1, which is 1, 2, and 3, and vector 2, which is 4 and 5, it gives you the combination 1 and 4, 1 and 5, 2 and 4, 2 and 5, 3 and 4, 3 and 5. So perfect. That's kind of like what I want to get in this particular thing, because I want to get all of these, the vector of these results, and I want to see afterwards. Then it actually turns them into a list, because what gets returned back from this is actually some kind of object. So I did actually have this in the beginning when I did write this code, but this is, well, we'll see back here, it returns you back a product object, and you actually have to convert this object is an iterator, and it's each item in it, and you'd have to like do a for I in this iterator and get each value out. But you can turn an iterator into a list in Python by just doing a list over there. So, and again, in the example code, so I could have used the exact example code. I didn't have to do from itertools import product. I could have just done itertools.product like that. So just imported itertools and done it like that. And we can see here on the outside that it's just wrapped inside of a list. So that's basically what I've done. I've copied, so I've used the prompt engineering to give me something that's relatively what I might look up in the docs, and that's a bit better like question wise, and then I can use that. Now I've got this list here, and this list now represents all the combinations of everything that we could have. So and we will actually see this because somewhere inside of this I did screw it up, so I did like a testing thing, and we'll actually see this run. But what we actually have is a 42 and a 56, then we're going to have a 42 and a 57, then we're going to have a 42 and a 58, then we're going to have a 43 and a 56, and so forth. So we get all of the different combinations of possibilities that happen. Now, my first guess was I went to itertools, and from itertools import combinations, but combinations wouldn't be the right thing, and permutations wouldn't have been the right thing. That's why I had to ask the question, because I couldn't quite remember what it was, and the I was going to say the GPT, the transformer, the large language model I'm using Corsair in this case, spat out the answer conveniently. So then, once that's done, we need to loop through it, and this is where like there could be one improvement straight immediately. Is I've just gone for a simple for loop, and I've just gone look for each of these possible outcomes that we get. So this thing here, I think, is going to produce it's going to produce 9 different outcomes over there. So each of these 9 outcomes, compare it to this. So compare all of these 9 to this value, all of these 9 again to this value, and all of those 9 to this value. So you've got 9 times 3, you've got 27 outcomes in your loop now. So for I in AB, and then for J in C vector. So for each one of these, because that's what we're going to do. So we've combined A and B. I'll actually draw this here. We combine A and B like that. So that's a 3 and that's a 3. You know, they get combined, and that's a list that is like 9 elements long. So it's got 9 elements in it. So it's a list like that. And then we're going to do a nested for loop over here on this one, and we sort of like check for each one of these that are inside of this, does it match any of these? Now what we're wanting to try to match is we want to, and I put the testing bit here so we'll see one of our trials, but we want to see if J, which is our value of C here in this case, and I typically use I in J because it's convention. I could have called for C in C vector, like for each item in there, but I use I and J. It's very, very, very key, but I, J, and K for the 3D vectors normally. So it goes through each one of those, and we want to check that the AB component of it. So we've constructed these 9 elements, and these it comes in these tuples. So the first element is 42, 56. So we get like this tuple over here, which is 42 and 56. And then we get the next tuple, which is 42 and 57, because it's these two, this one, and this one, and then we get 42 and 58. So like we're going through these tuples, and we want, and for all of these tuples, we want to see it. Now, I guess I could have done like a triple nested loop. That might have been like another solution. So just treated it like a matrix. So there's various different things. It might be a much quicker closed form solution. But anyway, I'm going through and I'm doing this comparison. The only good bit about the question was it said brute force. So let's brute force it. So this code will go through, and it's just going to test that the C is equal to the sum of the components of the tuples there, and the first element in a list is a 0th one, and the second element in the list, so the second element in the tuple is a 1. So we're just checking that, and if it does get that, then just return the I value, the first element of the tuple, which is the A value, then the second element of the tuple, which is a B value, and then finally J, which is the C value. So just return them, and if it doesn't equal that after it's looped through everything, well, we have to give something back, so let's just return a none just to give something back. So that's pretty much it, and I'm going to just remove all of these little pieces of lines over there and actually run the code. So this is all in a function over here, and then finally we're at the bottom, we're going to call our function R. I just use as a shorthand for result. It's going to be assigned to this variable, and then we can print out this variable, but remembering that we get to see all of this inside of the code, so that kind of like explains a little bit. So I just run this code by hitting F5, and we can see that it's just run down at the bottom. Maybe I should run it. Oh, there it is, all down at the bottom. And we can see it's testing, so I just put testing here. We're testing, it's done a 42 and a 56, and it's comparing it to 206, 42, 56, 200, comparing it to 207, and so forth. Now, none of these are going to be equal, because the 200 is far too far away for it to be equal. So actually, we get to see all of the combinations that are available. I've got to be careful when I use the word combinations, but I'm still like using it I think in the right term. These are all the 42 pluses of all of the different things, and these are all of the nested 56s sort of like inside it, so we can sort of like see what this is actually doing sequentially. It's doing that, and then of course it's comparing it to the 206, 207, 208. So here's the comparisons. And that's literally what it's doing, and it's just going through that, and it's going to repeat it again for, maybe I can actually scroll down on this now if I can. I don't know, but I can't quite scroll onto the right elements of it, or maybe I could, but it's going to do it for all of the 42s, and it will do it for all of the 43s, and it will do it for all of the 44s. Now that obviously won't work because the 200 was too large, but what we do know is something like 43 plus 57 is 100. So if this was something like 101, it would then, this number here would then be 100. This one would be 101, and this one would be 102, and it would then loop through them all. So I just run this piece of code again. So it's going to run through the loop, and it will just stop somewhere on this testing thing. And it stopped here, 42, 58 is equal to 100. So there we go, that's our answer. Now, generally speaking, I was just doing the print for the purpose of the code. Now, again, you might find quicker ways of doing it, because imagine that it was our last answer and it was very long list, two very long lists. It might be a bit more sort of like longer to get to the answer. So it takes this many steps to do it, literally because it's just doing it sequentially. But I kind of think this is a relatively quick method for doing it. So that's sort of like how that's left. And what we would normally do is something like this. So we might comment this out, or we can remove it all together. So let's just delete that from the code and run our code again one last time, and we should always get an answer back, which is either the answer. I wonder if I actually ran that. Let me get an F5 again to make sure that it runs. Well, I cancel on that. So let's just run that. And there we go, we just get our tuple as an answer. We could change it to a 102 over here, run it again. I wonder if it works. I think it should work for 102. Just go through a longer set of solutions. And indeed it does it for 102. We can do things with the functions. If I set it to if I set it to 103 or 104, if I made it too far apart, then obviously it wouldn't work and it would return a none. So again, if I would go as far as 105, there's no combinations of the maximum, because it would be like 44 plus 59, and would that equal 104? And we could just run that and just see, but I think the answer is no. I'm just trying to think off the top of my head, but I'm quite sure the answer is no, so we get a none back. And that's basically the answer to that question. If that question was asked a little bit better on the stack, it might have got some responses and some answers. I can't post an answer, I won't post an answer, but it's just quite an interesting little problem, and it gets us to use the itertools and the product function inside the itertools, and it gets us to do a nested for loop. So that's pretty much it, and I will leave it there. If you like this video, if you found it sort of useful, then hit the thumbs up button, the like button, the follow button, the subscribe button, share it with all other people, and that's basically it. I might just name this itertools, the itertools product function. That's it. Thanks for watching.